Hello everyone, welcome to the first lecture of DC circuit. In this circuit, we will study about node, branches and loops. I will give you a clear idea about these three topics so that you can have a strong basics in electric circuit. Now, let us study about node. It is very important to identify number of nodes in a circuit. The definition of node is that a node is the point of connection between two or more components. Okay, this is the definition of node. Node can be classified into two categories. Number one, that is principal node, and number two, which is simple node. Now, what is the difference between principal node and simple node? It is very easy. In a simple node, only two components are connected. Okay, in a simple node, only two components are connected. And in a principal node, more than two. Okay, more than two components are connected. I think now you have a very clear idea about principal node and simple node. To understand, let us draw a circuit. Suppose we have a 5 ohm resistor. Here is a voltage source having 10 volts. There is a resistor of 6 ohm and we have a current source having 2 ampere. Now let us identify number of nodes in this circuit. So our goal, find number of nodes, more specifically number of simple nodes and principal nodes. Okay, this is our question. Now move on the circuit. If we see in this circuit, see at this point, suppose the point is A. Okay, suppose the point is A. At this point, this 10 volt source and this 5 ohm resistor is connected. So by definition, whenever only two components are connected, then that node is called a simple node. So 5 ohm and 10 volt resistor is connected at this point. See, there is no component. There is no other component at this point. So this is a simple node. Now move on this point. At this point, suppose the name of the point is P. At this point, resistor 5 ohm is connected, resistor 6 ohm is connected, as well as this 2 ampere current source is also connected. So this is a point where more than two components are connected. Number 1, 5 ohm resistor, number 2, 6 ohm resistor, and number 3, this 2 ampere source. So this node B is a principal node. Okay, you can also name this point as P also, because they are common node. What is a common node? A common node is just a simple wire. Okay, just a simple wire. Okay, now move on at this point. Suppose the point is C. At this point, this 10 volt source is connected, the 6 ohm resistor is connected, also this 2 ampere current source is connected. So point C is also a principal node, and since this is a simple wire, so we can name this point C also and this point also C. So this whole straight line is a common node having the name C. So what is the number of nodes in there? Number of nodes, our answer, number of nodes is equal to 3. And how many primary nodes and how many, simple nodes and principal node? Simple node, just one, and principal node, 2. Okay, now let us study about branches. I think you have a clear idea about node now. We will study more examples later. Now let us study branch. So what is branch? A branch, the definition is, it is a single element. Okay, it is a single element. This is a very important word. This is a single element having node at each end. Okay, a branch is a single element having node at each end. If we consider this circuit, see this 10 volt resist. So this 10 volt is a voltage source. Okay, in this voltage source there is two ends at point A and at point C. So if we see here, there are two nodes at two ends. So this 10 volt is a branch. This 5 ohm resistor is also having 2 points, point A and point B, at the two ends. So this 5 ohm resistor is also a branch. Now if we see the 6 ohm resistor, see the 6 ohm resistor is also having two nodes. Number 1 is B and number 2 is C. So this 6 ohm resistor is also a branch here. Same thing goes for this 2 ohm current source. See, B, C. So how many branches are there? 2 ampere is a branch, 6 ohm is a branch, 5 ohm is a branch, and 10 volt is a branch. 1, 2, 3 and 4. So in this circuit we have 4 branches. Okay. Suppose the circuit, this is figure 1. Okay. So in figure 1 there are 4 branches. Okay. Let us see another example so that you can have a more clear idea. Here is a 5 ohm resistor. Suppose the voltage source is having 10 volts. Two ohm resistor, three ohm resistor, and the current source of 2 ampere. Okay, you have been asked to find number of branches. Okay, you have been asked to find number of branches in this circuit. So first of all, by definition of branch, we can see that a branch is a single element having node at each end. So your primary task is to identify number of nodes. Okay, then let us find node. This is a node, isn't it? This is a node because this 5 ohm resistor and 10 volt is connected at this point, and this is also a simple node. More specifically, it is a simple node. Now if we see at this point, suppose the point is B, at this point this 5 ohm resistor, 2 ohm resistor, 3 ohm resistor and 2 ampere resistor is connected. Because I said it earlier that whenever you see a wire in a wire, every point is same. Okay, so and this is a principal node because at this point this 5 ohm, 2 ohm, 3 ohm and 2 ampere, 4 components, okay, 4 components are connected at this point. So this point B or point B, this point or this point, you can say any of the point you want, but they are fall on the same node. Okay, they are falling on the same node. So this point B is a principal node. Now suppose let us consider this point C. At this point 3 ohm resistor is connected, 2 ampere current source is connected, 2 ohm resistor is connected, as well as this 10 volt voltage source. So this is also a node, and the name of the node is a principal node. And since this is the wire, so every point falls under the same node. Okay, now since we have identified the nodes, it is easier to identify the branches now. This 2 ampere this 2 ampere current source is a branch because this 2 ampere current source having 2 nodes at its 2 ends. 3 ohm is also a branch, C, B, C. 2 ohm resistor is also a branch because first point is B and second point is C. This 5 ohm resistor is also a branch because first point is B and second point is A. Same things goes for this 10 volt voltage source. First point is A and last point is C. 2 nodes at its 2 ends. So how many branches are there? Number 1, 2, 3, 4 and 5. So the answer is there are 5 branches. Okay, students. Now let us study about loops. What is a loop, or the definition of a loop? A loop is any closed path. A loop is basically any closed path in a circuit. So I think you can understand about a closed path. See, in this circuit, this is a closed path. See, if you start from point A, you can go to B, then C, then you can go back towards point A. So the path is closed. So this is a closed path 1. This path, it is also a closed path. Closed path B, this is also a closed path C. Okay, closed path A, so it is our loop 1. Closed path 2, so this is our loop 2, and closed path C, so this is our loop 3. Okay, so students, I think now you can identify number of node, branches and loops in a circuit. Now there is a network topology and or fundamental theorem in network topology. A theorem is that this theorem is very important theorem and this theorem deals with node, branches and loops and the relationship between these three things, these three quantities, node, branches and loops. The theorem is that a network having B branches, okay, a network having B branches, N nodes and L independent loops satisfies the fundamental theorem, that is B is equal to L plus N minus 1. Okay, this is a very fundamental theorem which deals about the relationship between branch, loop and node. So whenever you have the knowledge about number of loops, nodes, then you can identify branch. See, there are three unknowns: branch, loops and nodes. If we can identify any two of these three quantities, then we can identify the third one very easily. So students, to understand the theorem in more convenient method, let us see another example. Okay, let us see another example. Here is a 1 ohm resistor. Here is a 2 ohm resistor. Five ohm resistor, 10 volt source and another resistor having 4 ohm. Okay, the question is, find the number of nodes, branches and loops. Okay, you can pause the video and do the example by yourselves, then you can see my answer and then I think you have a clear idea. I will give you the answer now. Firstly, let us identify the number of nodes. Okay, the number of to know the number of nodes, see, this 1 ohm resistor, 2 ohm resistor and 5 ohm resistor is connected at this point. So the point we can name number 1. Okay, at this point this 5 ohm resistor, 10 volt voltage source and 4 ohm resistor is connected, so we can name the point as 2. So this is node 2 and this is a common node. The common node is 3. Okay, this is a common node having 3. This is 1, this is 2. So how many nodes are there? The nodes or number of nodes is equal to 3. Now, how many branches are there, students? See, this 1 ohm resistor having 2 nodes at its two end. So this is branch 1, this 2 ohm is branch 2, this 5 ohm is branch 3, this 10 volt is branch 4, and this 4 ohm is branch 4. So sorry, branch 5. So now number of branches are 1, 2, 3, 4 and 5. Okay, so number of branches are 5. So since B is equal to 5, N is equal to 3, now we can identify the number of loops, because we know from network theorem B is equal to L plus N minus 1. Okay, so 5 is equal to L plus 3 minus 1. 3 minus 1 is 2. So 5 is equal to L plus 2, and finally L is equal to 3. So number of loops in this circuit is 3. See, this is loop 1, this is loop 2, and this is loop 3. Okay, I think you have understood this example. Let us go to another example now. So students, let us consider another example so that we can have very clear idea about this theorem. Suppose you have given this circuit and you have been asked to identify the number of nodes, branches and loops. Okay, so you can pause the video and can do the example by yourself. See, let us firstly identify the number of nodes in this circuit. See, this is node 1. Okay, because 1 ohm and 15 volt resistor is connected at this point. This point is also a node. We can name the node as 2 because 1 ohm and 5 volt resistor is connected at this point. This is our node number 3 because 5 volt and 5 ohm resistor is connected at this point. This is our node number 4 because 5 ohm and 2 ohm is connected at this point. This is our node number 5 because 2 ohm and 15 volt is connected at this point. And each of these node is simple node. So number of nodes is equal to 5. So number of branches, how many branches are there? This is our branch 1, branch 2, branch 3, branch 4 and branch 5. See, this 15 volt is a branch, this 1 ohm is a branch, 5 volt is a branch, 5 ohm is a branch, 2 ohm is a branch. So number of branches is also 5. So number of loops, we can identify the number of loops from the theorem. The theorem is B is equal to L plus N minus 1. So B is 5, N is 5 minus 1. So 5 is equal to L plus 4. So 5 minus 4 is equal to 1. So L is equal to 1. So how many loops in this circuit, students? There is one single loop. So I've tried my best to give you a clear idea about node, branches and loops. If you have any confusion or any difficulties, you can say in the comment box. And that's for today.